Hi everyone, this is Zara from Global AI Hub and this is our third webinar in the series of webinars. This webinar is about introduction to machine learning and deep learning. And today our guest is a Google developer expert and a machine learning engineer, Arnaldo Gualberto. So please welcome Arnaldo.
Okay.
Hi Arnaldo, how are you?
Hi, everyone. I'm fine.
Would you like to give us a little background about yourself?
Sorry, it was hard to understand you.
Would you like to give us a little background about yourself?
Actually, I will do it in my lecture. So I introduce myself in my lecture too, so I can make it in my lecture.
All right then. Hope you have a good time and best of luck.
Okay, thank you. So hi everyone. That's a pleasure to me being here talking about machine learning, deep learning for you. I had prepared a Slido link for everyone interested in making a question during the presentation. So if you have any question during the presentation, go to the Slido link uh, I sent for you, and you can make the question. And at the end of the presentation, I will go back to the Slido and I will read them all and ask you and answer you. Okay. So I will start sharing my screen so you can see my presentation. Okay. So okay, let's start. Um, can everyone see my screen, the slides? Can you see my slides? Can someone give me some feedback about it? Could you see my slides? I didn't. Okay, I suppose yes then. So today we're gonna talk about a little about machine learning and deep learning. Actually, I want to talk about some projects I developed with machine learning and deep learning. So I will try to inspire you studying about it. And yeah, that's it. So for those who don't know me, my name is Arnaldo Roberto. I am actually I am currently a machine learning engineer at Wildlife Studios. That's a game startup company, and I'm also a Google Developer Expert on machine learning. For those who don't know what's a Google Developer Expert, basically it's a program from Google that recognizes experts in some areas. In my case, I am the expert in machine learning, but there are experts in many areas. There are experts in Android and in Flutter, in IoT. Basically, every technology that Google used will be Google developer expert in that area. In my case, I'm machine learning. In Brazil, we have six or seven people in developer experts in machine learning, but in the world, I think it's more 120, more or less. I'm also doing a PhD in deep learning, and that's it. So basically, I believe most of you have already heard about deep learning. So we have a lot of expectation about deep learning. We can see a lot of news about deep learning, like, oh, there is a deep learning algorithm from Google, for example, that can recognizes X-ray images better than humans, better than experts, or there's a artificial intelligence that can drive better than humans. So there is a lot of expectation about the deep learning, like it was the Skynet, but actually we have a lot to improve yet on deep learning. We just start about studying in deep learning. We have a long way uh, to study about this. And for example, in the reality, we can see here are images from of dogs and muffins, and they are all recognized by the same class by a deep learning algorithm. That's a real output from a real deep learning network, and we can see that for you it's very easy to see the difference between the monkeys and the dogs, but deep learning algorithms can still make some mistakes about it, and you have a lot to improve yet. So basically, today I want to talk about how is deep learning on practice. So deep learning practice is a very hard task, and you spend a lot of time tuning your hyperparameters and testing your network, evaluating your network, spend some time deploying your model, and I want to talk about this. I want to talk about deep learning on practice. So just my history with deep learning started in 2015. Actually, 2015 was a very crazy year to me. In August, I got married. In the October, I finished my master in science. And in October, I went to London to start a PhD. And in December of the 2015 was my first contact with deep learning. So that's a funny story because I remember when I was in my graduation, um, I used it to hear about deep neural networks. It was not deep learning by that time yet, but I used to hear about the neural networks, and I remember that I used it to thought to myself that, oh my god, neural networks are very hard, are very complicated. So I think I will never study about this. That's not for me. But in 2015, in December of that 2015, I had my first contact with neural networks and deep learning, and I remember that I felt in love about it. I remember that I started to study a lot about it, and I remember that I spent my birthday, my Christmas Eve, my New Year's Eve studying about deep learning. So I loved that so much. But in 2016, January of 2016, to be precise, I received an email from the university I was doing my PhD, basically saying the following: "Good morning, Mr. Arnaldo. Your sponsor hasn't paid your taxes yet. If they don't pay, you have to." And there was, uh, and they have attached 2,500 uh, taxes in that mail. So I didn't have that money in my pocket. I didn't have that money in my saving account. I didn't have that money anywhere. So I could not afford it. So basically, at the same time, I answered the email. So I said, "Where do I sign my withdrawal?" To withdraw. So I had to leave my PhD in progress, and I had to come back to Brazil. But since once I come back to Brazil, I had a lot of time. So I decided to spend a lot of time studying about machine learning and deep learning, since I have loved it about it when I studied in London. So I spent basically most of my year of 2016 studying about machine learning and deep learning. So here you can see some courses I did in that year. And here's not all the courses I did, but the most relevant ones, the courses I recommend you to do too. And in the October of 2016, I received an email from the company I used to work on, basically saying the following: "So hi Arnaldo, we need your freelancer to a brand new project. What do you say?" So I had no money, I had no job, so, and I had already a house to take care of. I had already a wife to take care of, and I answered, "Where do I sign?" So I started as a freelancer in that company, and my first project was basically the following. So the problem here is we want to detect the traffic lights, so in the middle of the street. So basically, we put it a webcam in behind of the rear view mirror of the car, and we started working with the car with this webcam, and we started recording the street. And first, and we want basically achieve two things. First, we want to detect the traffic light, so we want to know where the traffic light is in the image. And second, we want to know what's the color of the traffic light. Also, um, in other words, we want to classify the traffic light. So basically, to make this project, I recorded around 23 videos uh, that sum up to up to 3 hours of content. And for each frame of each video, I labeled where is the traffic light. So in this frame, for example, I labeled, oh, here's a traffic light and this traffic light is red. Here's another traffic light and this traffic light is red too. In the other frame, here's a traffic light and this traffic light is green. In the other frame, here's a traffic light and this traffic light is yellow. So I did that basically 5,000 times, and it was a hard job, but after that, the result of my system was like this. Um, so you can see that, let me start over. So you can see that my system was able to detect the traffic light and classify it in red, yellow, or green. So you can also see that my system was able to detect different shapes of traffic lights. Here in Brazil, we have the traffic lights can have different shapes, but my system was able to detect all these shapes and classify them as well. Okay. So after this project, my freelance contract was extended, and the next project I worked was basically the same thing, but now for stop signs. So basically, the idea is the same, but instead of detecting traffic light, we had to detect the stop signs. So in this case, I just needed one video of 6 minutes, and I just needed to label 70 signs around 70 signs, because as we know, the stop signs have more constraints about their shapes. The traffic lights can have a lot of shape, but the stop signs, they usually are, they have 8 sides, they are all red, they have a stop right in the middle of it. So since they don't have too many shapes as the traffic light has, so it was much easier to develop this project. So in the end, the result of my project was like this. So you can see that when my system sees a traffic light, it detects and say, oh, here's a traffic light. Oh, here's a stop sign, sorry. Let me show you another other examples. So here's a good one. So in this case, you have stop signs in both sides of the street. So you can see that my system will also able to detect them. Okay. Okay. So after this project, my contract as a freelancer was extended one more time, and now the project, the problem here is the following. Basically, uh, now we want to use the same webcam that we are using to detect the traffic lights and the stop signs to estimate the distance that our car is from the car in the front of us. So we want to estimate using only the images from the webcam how far we are from the car in front of us. So we have no information about a distance sensor, for example, or an ultrasonic sensor, for example. We only have the information about the image coming from the webcam. So for this project, I used 3 videos of 10 minutes, and I made a machine learning detector to detect cars, and I just need to label around 200 cars. And the result of this project was like this. I think this is one of the most amazing projects, because it's very nice to see. So you can see that my system can detect the car in the front of us and can estimate the distance using only the image that comes from the webcam. So you can see, for example, it detecting the car in front of us, and it's saying, oh, it's about 10 meters to 11 meters, 12 meters from our car. So basically, that's it. And after this project, my contract was extended one more time, and basically the problem here is basically is, so that company that I use to work on, most of their clients are driver schools. So here in Brazil, basically when you want to acquire your driver license, basically you have to attend first theoretical classes and later practical classes. So in these theoretical classes that we are going to talk about this now, basically when you have to attend these classes in the classroom, basically first you have to identify yourself. You have to verify your identity using your fingerprint. Then you go to watch your class, and in the end of your class you have to verify your identity by your fingerprint again. So there was some fraud cases that people use it to verify the fingerprint in the beginning of the class, but they use it to go home, and in the end, instead of going to the class, and in the end of the class they got back to the driver schools and verified their fingerprint again. So basically, to our system, it was okay. So we want to stop that fraud. So was our idea was, so we will keep verifying people by their fingerprints, but we will also verify if their people are in the classroom watching the class. So we will detect people inside the class and we will verify if that information is okay with the people that verify their identity by their fingerprint. By their fingerprint. So so basically, for this project, we developed a face detector to detect people inside the classrooms. And for this project, we had 8,000 images, and for all these images, we basically did the same thing that we did for the traffic lights. So for this frame, we labeled, for example, oh, here's a people, here's another people, here's a people, here's a face. Actually, here's a face, here's another face, here's a face. And for this project, when you want to make a detector using machine learning, you also have to teach your model what's a known faces. So we also have to label what known faces is. What's an example for known faces, for example? So known faces can be the wall, the floor, the desk, a notebook, something that's not a face. So basically, we labeled a lot of faces and known faces. And you can also ask me, why do you need more known faces than faces? So that's a good question, actually. And the answer for that is that if you think in the real world, the distribution of known faces, the distribution of it, the distribution of what's not a face is much larger than the distribution of faces. So we have in the real world we have more things that are not faces that are faces. So basically you have to map the distribution of the real world for your model too. So that's very important. So that's why you have too much more known faces than faces, for example. So basically, we trained a model for that, and the result was like this. So before of that model, we used it to use the standard face detector like the OpenCV face detector, and but the OpenCV face detector was very good, but they are only able to detect faces in frontal positions. They are only able to detect faces looking for the camera. So you can see that the model I trained it can detect faces in every position, basically. So it can detect faces in frontal positions, in side position, in back position, and it was better than the OpenCV detector, for example. So I think that so we increased our results by a lot using this machine learning detector for faces, and that's it. So here you can see some examples of the image we trained our model. So you can see there is no standard about the position of the camera. There is no standard about the position of the students. There's no standard about the classroom by itself. So we can see that we have a lot of faces in different positions and have a lot of students in different positions. So we can make any previous assumption about the image. So I think the result we achieved was very good. So we can see that we also have different problems like occlusions by other faces or by heads or caps. And we can see that that's a very difficult problem, but we achieved very good results. So after these four projects, I was finally hired as a researcher in that company, and the first project I developed was the liveness detector. So basically, the idea here is we want to know if the person that is being show to the camera is a real person or not. Sometimes we can, for example, we want to know if the person showing for the camera is a real person, or for example, it's a picture from a picture, so it's not a real person. So basically, for this problem, we have 2,000 images from real person and 2,000 images from fraud fraud cases. For example, that's a picture from a picture or picture from a video, and I think it's better to see in the video itself. So basically, the result of this project is this one. So you can see that when I am the front of the camera and a real person, the system says that I'm okay. I get back to not okay because I restart the analysis every time I got an okay. So you can see that when I'm in the front of the camera, the system uh, can tell that I am okay, that I'm a real person. But you can see that now I'm gonna show for the system a picture from me. It will never say that I am okay, and now I'm gonna see a video from me. So I'm blinking my eyes, I'm moving my face, and you never say that I am a real person. But when I get back to the camera, you'll be able to realize that the system can now, okay, that's the real person. Okay. So uh, one fun fact about this project is that we achieved a very good accuracy. Actually, what it was 99% of accuracy, and it was very interesting because it taught me that it taught me that when I have a very good system or a very poor system, you have to inspect it again. So in this case, we achieved a very high accuracy, but when we deployed this model in production, we got some bad results. And this project taught me that you have to inspect your model in very good results and in very bad results as well. So basically, when this happens, this basically one of the first things I want you to remember from this lecture. So when you have a very good system or a very bad system, most of the time the problem is related about your data. So in this case, realize that we had only a few examples, 2,000 images. 4,000 images is not enough to train a real system to detect the liveness of a person. So yeah, that's it. So uh, after all these projects, uh, basically I started introducing machine learning for that company. Before I started working there, all their solutions are based on computer vision, on classical solutions, classical techniques. And after I started in this project, in this company, I started moving our current solutions to current computer vision solutions to machine learning solutions. And I think that was amazing. I started to introduce machine learning as a daily basic technique for us, and I think that was amazing. So after until now, I just talked about machine learning. So you can ask me where deep learning on this lecture. So basically, my history of deep learning in that company starting in 2017. They paid the course to me in Unicamp. That's one of the best universities that we have here in Brazil. And so I went to Unicamp to make a deep learning course. I remember that I have already by that time I had some knowledge about deep learning, but in that course I learned a lot more about deep learning. So I had the opportunity uh, to learn more about deep learning, learn more about deep learning techniques, to make a lot of hands-on in a lot of techniques in a lot of things about deep learning that I had no practice. So I think this course was very good to me. It was a very good opportunity to increase my knowledge about deep learning. And I remember that I liked that course too much that when I got back to the company, to that company, I promised to myself that in 2 years I wanted to close the research department of that company. So basically, I want to apply deep learning in everything, in every the problems we had, so we can solve all of them using deep learning. So in 2 years, I want to have all them solved, and I want to basically close the research department. Maybe you can think that it's a very big promise I was doing to myself, but we're gonna back later to this project and see if I achieved this or not. Okay. So when I got back, so I decided to uh, start the first deep learning company project of that company. So basically, if you wanna if you wanna uh, do a deep learning model, you basically have at least two requirements. The first one is that you need a lot of data points. It doesn't matter if it's images or if it is rows in the tables. It doesn't matter. Basically, you need to have a lot of data points. So how much is a lot, right? Basically, I used to say that to make a deep learning model, to train a deep learning model from scratch, you will need for at least million of data points. It can be millions of rows in a table, or it can be millions of images. So if you have, for example, hundreds of thousands, that's okay. In most of cases, that's gonna work too. If you have dozens of thousands, it will depends. Not all the cases it will work, but it depends on your problem. If it is very easy, maybe it can work. But if you have only hundreds or a thousands of images, probably it won't work to train a deep learning model from scratch. So I know that. And the Classroom project, I had basically hundreds of thousands images, 40,000 faces and 90 non-faces images. And so we had hundreds of thousands of images, so that's okay. But the second requirement is that you need to use a GPU. But by that time, we couldn't use a GPU because most of the clients of that company, we used to work at the systems in the client's computer. So we could not say to our client, we couldn't say to our client, oh, we now have deep learning systems when you're going to need to buy a GPU to run our system. No, we could not say that. So we couldn't use a GPU. Uh, so basically, we had to make sure that our system was able to run on a CPU. So okay, so I trained a deep learning model using these faces and non-faces and using CPU too. But the result was not very good. The result wasn't better than our previous result. So I think the problem was my data, and I decided to increase the size of the data set. So I I got three more. I got 120,000 faces. That three times more larger than the 400,000 faces, and I doubled the non faces images. So we had 90,000, and now we have 180,000 non faces. And since it was my first project related to deep learning, I decided that using real world data, yeah, using real world data, I decided that I would try everything that I heard about training deep learning models. So if someone said that more layers works better, or more filters works better, or using dropout is a better regularization technique, or something like that, I use it. I would try. So basically, I ended up training more than 550 models. So I trained a lot of models using this data set to train a new face detector, and the result was improved by a lot. So, for example, using the standard face detectors like the one from OpenCV and DLive is another computer vision library that's basically very similar to OpenCV. So using their standard face detectors, our usage was about 60. 60%. So it basically it means that for 100 people in a classroom, we were able to detect 60 of them by using the machine learning solution that I showed in the video. It was improved to 85%. And by using the deep learning model that I trained from scratch using that data set, we improved it to 89%. So basically for today, for basically for 100 people in the classroom, we are able to detect 89 out of 100 people in the classroom. So that's really amazing. So you can see that, for example, my system is able to detect almost everyone in a classroom, no matter the position of the camera, no matter the position of the faces, no matter the lighting conditions. For example, you can see that here in the bottom left corner, we have a very darker image, but my system was able to detect almost everyone in the classroom. So I think that was really amazing. And I also decided to uh, evaluate my model in our data set. So here, for example, you can see that here are the true positives of my network. So here are basically the faces that my model is able to detect. So you can see that it can detect faces in different positions, in different angles, in different image qualities. So for example, this image and this one are very low in quality. It can also detect high occluded faces, for example. So basically, my system ended up with a very good solution. And I also evaluate my system in terms of false negatives and false positives. So basically, in the false negatives, basically it means that here are the faces that my system is not able to detect. So you can see that most of the faces that my systems cannot detect are about the faces in back position. So basically, that's a good indicator that in our data set, we don't have a lot of faces in back position. And I think that makes sense. Since we have a classroom data set, most of the time, the only person in the back position will be the teacher. So we're gonna have too much more faces in front of the camera, and just a few faces in the back position. And the false positives is basically the faces that my system said that is a true face, but it was not labeled in the data set. So, and you can see that it's already have it have a real false positive like this is a mouse, this is a projector, the desks and so on. But we can see that in the false positive they had a lot of real faces. So it's a good indicator that in our data set we didn't label all the faces, so we have also some mistakes in the labeling phase. But there are two cases that I think is very interesting. For example, this face here is a face in the notebook of the teacher. So of course it's not a real a student in the class, but my system was able to detect this very tiny face in the notebook of the teacher. And this face here is a tattoo from a guy, so the arm of a guy. So my system was able to detect the face even in the tattoo of a guy, and I think that's very amazing. So I also decided to compare my system um, to another solutions from big companies. So for example, here's the result of the IBM face detector, IBM face detector in our image of from our data set. So you can see that it detects about 4 people. This one, and this one, but it has some false positives, like this one here and these ones here. So here's the result from the Google face detector. It detects 3 faces, but at least it has no false positives. Here's the result from the Microsoft, for example. So it detected five people in the classroom, but at least has no false positives either. And here's a zoom from the Amazon face detector was one of the best that I tested, but it was able to detect this guy using a hat and this guy in the back of the class. And here's the result of my system. So it was able to detect basically everyone in the classroom. So I think that's really good. Okay, so basically I developed that system using Python. I developed the model using Python, and in that company, most of the system was deployed in C++. So to make I had to make that system to work on C++. So the TensorFlow is written on C++. The core of TensorFlow is written on C++, but the API for Python is much larger and much better than the API for the C++. And that's very interesting because C++, the core of TensorFlow is written in C++. So that was my first problem. I had to make my system work on C++ using TensorFlow. I had to make this work on Windows too because TensorFlow was originally made to work only on Linux, and I had to make it work on the Visual Studio. So if some of you have already worked on Visual Studio, you know that it's very hard to set up your project on Visual Studio. So for my lucky, there was a page on the I think there is a page already yet on the TensorFlow documentation that was basically how to make TensorFlow works on Windows and Visual Studio using C++. So I downloaded that project, that demo project, and for my surprise, it's working on my computer very good. So I thought to myself, okay. But when I tried to deploy our model in our system, it didn't work. It gave me that error. So I didn't know what that error meant by that time, but we're gonna we're gonna talk about this now. But basically, you can see that it's saying that this MD dynamic release does not match with this MT static release. So what does it mean? So when I got this error, I was like that because I was thinking to myself, oh my God, the company paid a deep learning course to me. I got back to the company and I developed a deep learning model that I said to my boss that it was better than our previous solution using machine learning. But now I cannot make it work I cannot deploy this model in our system. So I was very anxious about it. So the first thing I did was to understand what that problem means. So basically, when you build a C++ project and you're gonna generate an executable file, basically you have two options to generate this executable file. The first one is using -md. Basically, it says that imagine the following situation. I generate an executable file and I want to send to my friend this file so he can work here this in his computer. So if I generate this executable file using the option -md, that's the default option. Basically, to make it work on my friend's computer, I need to send him the executable file plus all the DLLs that my project depends on. So I need to send him the executable file plus for example, the TensorFlow DLL, the OpenCV DLL, and my system will also depend some Windows DLLs that if the Windows update automatically in the computer of my friend and it updates some of these DLLs, my system will stop working. So the other option, the -mt option, in this case, if I generate a executable file using that option, all the code that from those DLLs that my project depends on will be incorporated inside the executable file. So if I send to my friend only this executable file, I am sure that it's gonna work very well, because everything that every code that my project depends on is already inside the executable file. So of course that's the how we used to work on that company, because we want to send our executable file to our clients, and we want to make sure that it's gonna run in their computer without any problems. So basically, I went to TensorFlow repository and I found an issue basically with that title, building TensorFlow on Windows with dash nt option. That's exactly the case I had, and it was opened by this guy, Alex Petrenko, and it was closed. So it was a good indication that it was already resolved. So, and it was already resolved, but in the end of the issue, Alex Petrenko said that, okay, guys, so I was able to solve this, so I'm closing the issue, and that's okay, fine. So, but I had to also achieve this. I also had to build TensorFlow on Windows using the dash nt option. So, and I didn't know how to do that. So I sent an email to Alex Petrenko, basically saying the following. So, hi Petrenko, you are the only person I know who was able to build TensorFlow with dash nt. How did you achieve it? And Petrenko said, hi Arnaldo, it was pretty hard, but you only have to blah, 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 and then blah, blah, blah. And basically, Petrenko is a Russian guy, if I'm not wrong. But I talked to him in English, but basically what he said to me was Greek. I didn't understand a single word, but there was something that he said on that email that I never forgot. He said basically, however, I don't recommend you to do that. But I had to do that works because I said to my boss that I trained a deep learning model that was better than our previous machine learning solution, and I had to make it that works. So basically, my day at the company was like this. So I went to the company and I tried something to build TensorFlow with that option, and I failed. And I think I try and I fail. I think I try and I fail, and I entered in a loop basically for 4 months. So I spent 4 months trying to build TensorFlow to work on Windows, and that was a very hard task. And after some time doing that for a long time, you can imagine that usually when I got home, I used to be like that. So I was very sad because I could not deploy our deep learning model in production because I wasn't able to build TensorFlow for Windows. But after some time, I was able to do that, and you can see that how happy I was because instead of taking a picture, instead of taking a screenshot from the instead of taking a screenshot, I took a picture from the screen with my cell phone. So you can see that I was very happy, and I sent I sent that picture for all my friends, and I said, oh, I got it, I was able to do it, our system can be deployed now. So after some time, our system was deployed, and I think that's a very important day, because in that day, we deployed our first deep learning model. So that day, I changed that company to a deep learning model, a deep learning company. So I think that's very amazing result. So when I remember that when I entered that company, it was totally based on computer vision techniques, and I started introducing machine learning. And after that project, I turned that company in a deep learning company, and I think that's very amazing. So after this project, we started to make everything working with deep learning. So we start turning all projects using deep learning. So I asked for a GPU, and they gave me, and we start training everything using GPU. And the first project, for example, we did was the enhancement. What is it? Basically, here on the left, you have the original image that came from a fingerprint sensor, for example. So that image is not good for verification, is not good for identification. And one of the process that we do, we apply for that image is the enhancement process. So basically, that's a process that you turn these images on the left and the images off the right. So it will turn this image in a black and white image, which is much more better for recognition. It has no noise, for example. And basically, we trained a deep learning model to basically the model would uh, learn how to paint the original image in the enhancement image, in the black and white pixel, in the black and white image. So we trained a model for that, and we had 120,000 images. We achieved the state-of-art results. We published a paper about our method, and but in GPU it was working about 7 frames per second, but in CPU it took 12 seconds. So we never deployed that model, but we achieved very good results, and that's great. Uh, the other problem we applied deep learning was the classification for fingerprint. So basically, if you look in your finger, you can see that your finger, you have one of these patterns. So basically, your fingerprint will have one of these patterns. You'll be classified in one of that classes. And why this is important? Because imagine that we have a 1 million data set, image data set of fingerprints, and you want to identify someone in that data set. So why we would compare this image with all the images in the data set if we can only compare that image with the image from the same class? So we basically trained a deep learning model to classify the fingerprint images in one of these 6 classes, and we trained it using only 4,000 images. We uh, also achieved state-of-art results. Unfortunately, we never published a paper about that, but today we are not the state-of-art anymore. But we achieved a very high accuracy of 90.2%, and that was very good. So that was another deep learning solutions we developed in that company. And after this project, uh, we decided that we would not train more deep learning models from scratch. We would start using pre-trained deep learning models. So basically, for example, in this project, we want to detect the people inside of a car. So basically, in Brazil, when you attend the practical classes, when you want to achieve your driver's license, you have to attend your practical classes when you learn to how to drive. And basically, we have a cell phone in the car that is recording everyone inside the car, and basically want to detect who is inside the car. So basically, for this project, we trained deep learning, a people detector using deep learning, and for this project, we used a pre-trained model that is already trained to detect people, and we only adapted this model to our problem. So, for example, we had in this case 15,000 images, and inside these images we labeled 18,000 people, and we can see how difficult this project is. So, for example, here you can see that we have a cell phone inside the car that's recording everyone inside, but we have a lot of problems. For example, as in the classroom, we don't have a standard about the position of the cell phone. Sometimes the faces are occluded. Sometimes the faces are not showing completely in the image. And we also have classes during the night, and that's a harder problem because the quality of the images are worse than before, and we also have the same problems that we had before. But we trained a deep learning detector that was able basically to detect everyone inside the car. Before the people detector, we used it to use a face detector. So in sometimes our face detector wasn't able to detect the people inside the car, but using a people detector, we were able to detect everyone inside the car, both in the day image as in the night image. So you can see that our people detector are very good. So basically, we choose it three pre-trained models, and basically now we have a trade-off between the accuracy and the speed of detection. So using machine learning, our previous results was about 93%, and using deep learning, we improved that result, but we now have a trade-off between the speed and the accuracy. So for example, we have a deep learning model that is able to detect almost everyone in the image, but it takes 6.4 seconds to run in a single image using CPU, of course. But we also have another deep learning model that can run in about 8 frames per second, and it detects almost 95% of the people inside the car. So I am about to finish. There are only three more projects that I want to show you about. Uh, just a reminder. So if you have any questions, please ask on the Slido. And basically, okay. So to finish, the first project I want to finish the presentation is this one. So I believe that some of you have a passport, and I'm not sure if you know, but there is a international standard about image passport images. So this standard says some requirements that the passport image must obey to be a valid image. So, for example, um, you can't be looking away. You can't be wearing sunglasses. The background cannot be varied. You can't be with your eyes closed. You can't have red eyes. You can't be using a head cap. You can't be with your mouth open, and so on. So there is a lot of requirements about the passport image, and in that company, we had a system to evaluate images within that standard, but basically we had one one machine learning algorithm to evaluate each requirement individually. So basically, we had 23 algorithms, one for each requirement. So basically, we want to apply deep learning for that system to see if we can improve, if we could improve our results, or at least make it easier to evaluate. So basically, we decided to apply deep learning in two different cases. The first one is about the head cap requirement. The head cap requirement, even by using machine learning or using computer vision, is very hard task because it's very hard to using classical techniques to see if a person in the image is wearing a head cap or not. So we decided to train a deep learning model for decide if a person is wearing a head cap. So, but for this project, we only had 1,000, basically 1,000 negative images, so people not using a head cap, and only 123 positive images, or in other words, people using a head cap. So, do you remember that I said to train deep learning model from scratch, you're gonna need at least hundreds of thousands images to train deep learning model. So in this case, you have only 1,000 images. So that's a very small data set. And if you want to try to train a deep learning model from scratch, it's not going to work very well in production. So basically, when you have this situation, one of the things that you can use is the transfer learning technique. So what is transfer learning? Transfer learning is basically a technique for deep learning that you're gonna use a pre-trained model, and you're gonna use this pre-trained model to adapt to your new problem. So that's what's our case. And it works very well when you have just a small data set like we had, and we apply transfer learning to make it work, and we achieved very good result. So I want to share this with you right now. So basically that was our result. So you can see, for example, it's saying that this guy is not wearing a head cap by with 100% of sure of confidence. Let me see. So, for example, this woman is not wearing a head cap. This guy is wearing a head cap with 100% of confidence. This woman too. This guy is, of course, it's more than head cap. It's for everything in your head. You can't be wearing nothing above your head uh, in a passport image. So basically, we achieve a very good result for different kind of images. And actually, this one was the systems I did that I trust the more. So I trust this system very well. He's very good to achieve to know if someone is wearing a head cap or not. Okay, so this in this project, basically now we want to segment the face of the image, the image of the face. Sorry. So basically, the idea here is we wanna segmentation. The segmentation is you the segmentation problem is when you paint every pixel from your original image in a color of one of the classes you want to segment. So for example, in this project, we have 8 classes. I'm not sure if I'm going to remember all of them, but basically, let me see. The classes were background, face skin, eyebrow, eyes, head cap, bird, and hair, clothes, and yeah, that's it. So that's the all the 8 classes. So basically, we trained a deep learning model. In this time, we trained it from scratch using only 700 images, and we want to segment the image of a face in 8 classes. And we developed a deep learning model that was able to run in CPU in about 8 frames per second. So that was very amazing, and the result was like this. So I think this result is very good because if you think that we trained this model using only 700 images, it did the model did a very great job. So you can see that it can segment the clothes, the skin, the eye, the eyebrow, the hair. Let me so for any person, for basically for any person in the front of the image. So you can see in this guy, I can detect his bird. So for this, so of course there are some wrong segmentations, but if you think that we trained this model using only 700 images, I think we achieved a very good result. And something important to say is that none of this person showing into the camera has been seen by the model in the training phase. So none of this person was seen by all this person is was never seen by the model, and I think the result was very good. And finally, the last project I want to talk about is the face pose estimator. So basically, we had about 68 points around the face. We use a D library to detect these points around the face. So basically, have points around the chest, the points around the mouth, the nose, the eyes, and the eyebrows. And basically, we want to use that point to estimate the face position in the 3D space. So we have only the points in the 2D image, and we wanted to estimate the face position in the 3D space. So that's very hard because you have no information about depth, for example. We only have the information about the points around the face. So we trained a deep learning model using 6,000 images, and our model was able to run in CPU in real time. So basically, the result was like that. So in face, we have basically in face position have basically 3 axes: the row, pitch, and yaw. Let me show you what does it means. So for example, when you make a yes with your head, it's the yaw position. So basically it's saying that I am with my face 1.3 degrees up. And if I go down, oh, sorry. When you make a yes with your head is the pitch position. So if your head is up, so I have 80 degrees up, and if I move my face down, it gets a negative pitch. The yaw is the movement when you make a no with your head. So for when your head is faced to the left, you have a positive yaw, and when your head is looking to the right, you have a negative yaw, for example. And the other axis is when you make a maybe with your head. So for this side, you have a negative row, and for the other side, you're gonna have a positive row. And you can also turn your face it to every position, to any position, and you can detect all the three positions at the same time. Okay, so just to finish, after all these projects, we ended up like this. So remember that I made a promise to myself that in 2 years I want to close the research department. Unfortunately, I wasn't able to achieve that promise. But after 2 years, that was our like we were at that time. So basically, if I had promised to myself that basically in 2 years I want to ended up with the computer visions. I want to finish the computer vision technique, the classical techniques we had in the company. Maybe it would have easier promise that I could achieve. But anyway, I couldn't achieve any promise. But I think we had I did a great job in that company because I turned that company into a deep learning company, and I think that was very good. Just to give you an idea, the classroom and the in-car projects, they were able to evaluate 207 classes in a month. That's basically 2.2 million images per month. So it's basically almost one image per second. So my deep learning models in production, they are evaluating a lot of images by second. So I think that's very good. So if I have to finish and give some tips to everyone who wants to study about deep learning or deploy models about deep learning. So basically, I have three tips for everyone. The first one is Python is the language that you have to study. Most of the deep learning frameworks, not only TensorFlow but also Keras and PyTorch, they are writing in Python, and most of the deep learning frameworks they are writing in Python. And of course, Python is the language you have to study if you already don't know about it. The framework I recommended is TensorFlow, especially the 2.0 version. I started to use TensorFlow on 1.4 version, I believe, on version 1.4. TensorFlow by that time was very hard to use. So after we had Keras that make the deep learning frameworks much easier to learn and to apply. And now today we have the TensorFlow 2.0 that is basically the Keras, but it's much easier. It's easier than Keras to apply, and it's faster than Keras too. So basically, I recommend you to study about the TensorFlow 2.0. It's a very easy deep learning framework to learn about it and to apply. And if you want to deploy deep learning models, I I suggest you to deploy your models as an API that your client calls these APIs, passing image or passing the data points, and you just return your result back. Because if you apply, if you deploy a model like this, it's much more easier to scale and to use it in production. So basically, just to finish, I like to finish my lectures with a sentence, and the sentence I choose for this time is a sentence from Abraham Lincoln that says, he said, "If I had 6 hours to chop down a tree, I would spend four sharpening my axes." So basically, I think this sentence has everything to do with the deep learning and data science and machine learning in general, because I used to say that you're going to spend most of your time seeing if your data set is good enough, is large enough, is clean enough. You're going to spend most of your time wrangling with your data set, making it useful to train your model. And basically, there is a joke of deep learning that says that in a deep learning competition, the winner is not the one who has the best model, but who has the best data set. So I think that's very true, because when I am about to train my models, I spend 80% of time working with my data set to make sure that it's good enough it will be good enough to train my models. So that's it, guys. If someone wants to know more about me, here's my website, here's my email. Please feel free to send an email asking for um, uh, everything you want to know about deep learning. You can, for example, courses to study or tips to deep learning. You can also see my GitHub. I have a lot of repositories about deep learning and machine learning in both Portuguese and English. And I also write something, and I also like to write about deep learning and machine learning on Medium. So if you want to follow me on Medium, you can see some things I write about deep learning on Medium. So that's it. I hope you like it. And before I finish, I would like to say it's a pleasure to me to be here talking about machine learning and talking about deep learning. I like to talk about it very much, and I hope you like it. And that's it.
So thank you once again for your
I can
great
see
talk.
there
Can you hear
is
me?
questions. Oh, how can I see?
Can
Let
you
me
hear?
see. Okay, there is no slide of questions. That's okay. And
Okay,
that's
so
it.
I will be reading out the questions to you. Okay, can you hear?
I can hear you, Zara.
Can you hear now?
No, sorry.
Wait, hold on. Can you hear me
Are
now?
you muted?
Can you hear now?
I
Sound.
can hear you.
Still no.
No. Okay, no, okay, I can. Sorry.
Now?
Yes, I can hear you now.
Okay, so thank you so much for your talk. It was really insightful and interesting. So we have a few questions and I'm going to be reading them out to you. So
Okay, okay.
first of all, we have a question. Did you use a special labeling tool for your model?
Yes, let me share my screen again so I can share the labeling tool I used to use. So my favorite label tool is this one, the label IMG, the label image. So I can send the link on the on the chat, so you can have access to it. So this is my favorite library because it helps you to label your objects in the image, and it's ported in the formats that is readable by TensorFlow. So I think this is my favorite one. It's very easy to use, and yeah, that's very easy to use.
All right. So your second question is, do you share your models or training data in GitHub, or are these restricted?
Um, some of the models I share the data set. So for example, the phase pose estimator, you can, if you go to my Medium, you can see that in the Medium post I will talk about the problem, I will explain the problem. I will also share the data set I used to train, and it also has a link to my GitHub project about that model. So you do have the Jupyter notebook I used to train, and you can train it by yourself and run it on your webcam, for example. For some projects, it was restricted, so I could not share any of the code or the data set. But there are some models and data set that I shared, and if you go to my GitHub or to my Medium, you can have access to it.
All right. Okay, so another question. This is hi Arnaldo, loving this webinar. Really informative. Can you tell a little about uses of ML and artificial intelligence AI in Brazil?
Okay, so I think in Brazil, machine learning is much more used than deep learning. We don't have we have a lot of companies that use machine learning, although some of them don't know too much about it. They use like a black box, for example. Deep learning companies is very much more is harder to see companies that use deep learning. I'm not sure how much, but it's not so usual that machine learning. In the company I am working now, the Wildlife Studios, that gay company, for now we are only using machine learning, but I also have plans to apply deep learning models in our games too.
All right, so I also have one question for you. So would you like
Okay.
a little bit about how your journey as a Google developer started? Like if someone is, aspiring to be a machine learning engineer, what would you recommend to them?
Sorry, the sound's not very good, but you want to me to talk about how to become a Google developer expert?
Google developer expert, and also like for someone who's starting out to be a machine learning engineer, for
Ah,
example,
okay.
recommend.
Okay. Understood now. So basically, I think the best advices I could give to someone about machine learning, deep learning, was the things I did to starting about it. So basically, to become a machine learning engineer and to become a deep learning engineer, I started studying a lot about machine learning, deep learning. As I said, I spent almost of 2016 studying about machine learning, making machine learning courses and making deep learning courses. So I spent some time studying about a lot about it. Started studying machine learning, deep learning as general, and you have some good intuition and good knowledge about it. Go to the area you like the most. So in my case, for example, I like neural networks, but my specific area is computer vision. And if you like computer vision, start studying more about this. If you like natural language processing, sound processing, I don't know. So start you studying about general things about machine learning, deep learning, studying the algorithms, studying the techniques, and later go to the direction you like the most. So, for example, computer vision or natural language processing. And if you have the lucky, you can search for a company that works with the techniques that you like the most, so you can start to work on that company to learn the other things about machine learning. So basically, know how to deploy your models, and that's it. Basically, that's what I did. What I did.
So thank you, and that was really insightful. And thank you for your great talk. Thank you for your time. So we wish you all the best, and bye bye. Thank you so much.
Okay, you're welcome. I like it that lecture too much. It was very good to talking about you. It was a pleasure to me.
Thank you. So Have a
Yeah.
nice day. Bye bye. So, thank you everyone for tuning in with us. Please stay tuned next week. We will be having another webinar. So, thank you so much. Bye bye and take care.